And this begins Pre-Calculus, Chapter 2, or Unit 2, Section 1. And what we're going to be doing is a little bit more than just factoring, because I'm sure you're confident, or you have figured out how to factor in Algebra 2. I'm confident in your abilities. But if you need a refresher, I would strongly encourage you to go back and review certain things like the greatest common factor and several other things. Because as I look at this first problem, when you factor, you would pull out an x first. So you have x squared plus x minus 6. And then what you do is look for factors of your last number. It could be 1 and 6, but the only way to get a negative is if one of these is negative, and 1 minus 6 does not give you 1. Same with 6 minus 1 does not give you that middle term of 1. So that doesn't work. So you could try 2 minus 3. Well, 2 minus 3 gives you negative 1 right here in the middle. So how about you just switch it, negative 2 plus 3. So the reason why we do that is now we have, we still have that x in front, but then your factors are x minus 2, x plus 3. And then when you use the zero product property, that means that the only way to multiply three things together to get 0 is if one of those three things is 0. So that's where we get x equals 0. The only way for this middle piece to equal 0 is if x equals 2, because 2 minus 2 equals 0. You don't care what these other numbers are, because anything times 0 is still 0. And then x equals negative 3. And you probably remember just a shortcut from Algebra 2 that if this is a factor, then the solution is the opposite. And as a reminder, we call them zeros because when you plug in these values in for x, you get it equal to 0. And what we have as the next thing is we already have the graph. The graph has a 0 at negative 3, 0, and 2. So this is the correct graph. So what they're trying to get you to realize, I guess I have that already. Sometimes we write them in braces, by the way, if we're just giving values instead of an interval notation. Braces mean it can equal. So what they're trying to get you to do is realize without a graph where the function is greater than 0. And I will show you how to do that. But let's first figure out where is the function greater than 0. That means above the x-axis. That would be from negative 3 to 0, union 2 to infinity. Which is very similar to number 4. The only difference is it can be on the x-axis as well. I guess I should write down. This is above. This one is on. This one would be below. Things you learned in Unit 1. The only difference then is for being on, you would have brackets then. And then being below would be, remember we go left to right, so negative infinity until we get to negative 3. And then from 0 to 2. And then the only difference, remember you always use a parenthesis with infinity. But the other values you want to use a bracket because that's when they're on the x-axis. So hypothetically, what if I did not give you the graph? Do you think you could come up with that value? Well, some of you might be saying, yes, you could do it. And the reason why you might be saying that you could do it is you may remember what is called end behavior, a cubic polynomial with a positive leading coefficient. But I'm going to show you a slightly different way that is also used in calculus. So we'll imagine for a second we already factored this. What do we say? It was x minus 2 and then x plus 3. And what we did first is we just identified the zeros. 0, 2, and negative 3. So what I'm trying to get you to do is what is called a sign chart. So this is difficult for students to get. So by all means, if you have questions, please let me know. And what we do is on the left-hand side, we put just those values, -3, 0, and 2. And then we put a number line down. And on the number line, we're also going to put, in order, -3, 0, and 2. So here's the premise, I'm going to go back to green, is this represents the x plus 3 term. Well, if I were to examine the x plus 3 term and plug in -3 into this problem, well, -3 plus 3 would give me 0 right here. All right, I'm going to change colors for a second. Now, what if I picked a number to the left of -3? To the left, let's say -4. Now, it doesn't have to be -4, but it could be. Well, what kind of number do you get when you plug in -4? Well, -4 plus 3 gives you a negative. So the only thing that I care about, so I'm putting a minus sign here. I think that confuses some people too. Because it doesn't have to be -4, it could be -5. Well, no matter what I plug in to the left of -3, for x, I get a negative value. Let me change colors. Well, if I pick a number that's to the right of -3, like -2, well, -2 plus 3 gives me a positive value. And notice I'm putting a positive between -3 and 0. But I could have also put a number between 0 and 2, like 1. Well, what kind of number do you get when you do 1 plus 3? You get a positive. And then pick a number to the right of 2. You get a positive. Now, the shortcut that people figure out is that you put a 0 where that value is, negatives to the left and positives to the right. All right? And that still works for x equals 0. You're going to put a 0 right here, but what term we're looking for is we're examining the factor for 0, which lined up with x. So again, I'm going to change colors. And if I picked a number to the left of 0, like -1, you see how my term is negative? And I get a negative over here for like -4, -5. Plug that in for x, you get a negative. And then to the right, I'll switch back to blue, they're going to be positive values. Positive values to the right. I'm going to do this one more time for x minus 2. So again, this term is representing x minus 2. So if I plug in 2 for x, 2 minus 2 gives me 0. Did not want that on there. But if I pick a number to the left of 2, let's say 1. Well, 1 minus 2 gives me a negative. Over here still gives me a negative. Over here gives me a negative. Do you see how I'm getting positive numbers? Sorry, negative numbers. I'm getting ahead of myself. So here's the premise. And we're almost at the end, and you don't even need a graph at this point, is we are going to multiply straight down. Because what we did is we put in values to the left of -3. And remember, this term was a negative to the left of -3. This term was negative to the left of -3. This term was negative to the left of -3. So a negative times a negative times a negative is a negative value. And why are we doing it this way? Is because we are finding all values for this expression up here. A negative times a negative times a negative. Well, is a negative greater than or equal to 0? No. So we actually don't want that interval. So let's move on to the next one. What about numbers between -3 and 0? Okay, well, we had a positive for this term. This term was a positive. This was a negative, this is a negative. So we have a negative times a negative times a positive. Well, we get a positive number. Do we want positive numbers? Are positives greater than or equal to 0? Yes. So we want that answer. So we want from -3 to 0. Why am I using brackets? Because it can equal. And one of these other ones is going to work as well. So again, how do you read this quickly? Because you'll probably want to do this quickly. So you go straight down. A positive times a negative is negative, but we don't want a negative. A positive times a positive times a positive is a positive, Okay, we want those. So from 2 to infinity. And look above on your notes. Did that match what we want? Yes, it did. So as we do more of these, I'm going to go a little bit faster. And if you need to re-watch this, hopefully I gave you a good explanation. And we can move forward. I think I can get the next one done without spending too much time. Now this next one, you may notice that we have 4 terms here. And you may have forgotten from Algebra 2 that we have this method called factor by grouping. And this one actually does work. It doesn't always happen that if you have 4 terms, you can factor by grouping. So what I'm looking at is grouping the first 2 things together, group the last 2. I would factor out a negative x squared. That's just me. So I'm looking at x plus 3. And I would factor out a 2 in this next one. X plus 3. Also, don't forget, you can always pause this video and try it on your own. Let's see, negative x squared plus 2, and then x plus 3. And if you set each piece equal to 0, because we are finding the zeros, right here's your product. You can actually jump ahead if you wanted to. See that it's going to happen at negative 3. Now this one, I don't know how good your arithmetic is. But if you set that piece equal to 0, I would probably add x squared to the right side. And when you square root it, please don't forget you get 2 answers, plus or minus root 2, which I'm sure some of you prefer that decimal 1.414 if you use a calculator. But this one's definitely x equals negative 3. So as you look at your graph, it's pretty evident there. You have the same answers, negative 3. I'm going to leave it as that plus or minus root 2. I just prefer that answer. Where is it positive now? From negative infinity to negative 3, union, negative root 2 to positive root 2. Where is it below the x-axis? Negative 3 to negative root 2, union, root 2 to infinity. And then this is really the same as number 2, except we put a bracket. I'm trying to go quickly, and hopefully you can read my handwriting. And this one's only different because it's got brackets with number 3. But then please don't forget that infinity is always a parenthesis. Let's see. I don't want to rush through the next one, so I'm going to pause the video here and pick you up on a new video on the next one.